Hi guys. So today we're going to look at solving multi-step equations. What happens when you have the variable on both sides of the equal sign? Well, what you need to do is you need to put them both on the same side because they're like terms. Remember, like terms are terms that have the same variables and the same exponents on the variables. Values without variables need to be moved to the other side. Values without variables are called constant terms. Then we continue solving by using opposite operations in the opposite order. So one way that we could say that is we could call that reverse BEDMAS. So opposite operations in the opposite order. So let's go through a couple of examples. All right, so for the first one, we've got two types of terms. We've got x terms, that's the 4x and the 2x. They're on opposite sides of the equal sign. And we've got constant terms. We've got the -5 and the +7. So we want to bring all the x terms to one side. I'll bring those to the left. And so I'll move that 2x over to the left-hand side. I'm going to leave the 4x there. And by moving it over, I mean I'm going to do the opposite operation. And so I'm going to subtract 2x from each side. And I'm going to bring the constant terms to the right-hand side. So that means I'm going to leave the 7 where it is, and I'm going to add 5 to both sides. And just as far as the highlighting goes, just that's meant to show like terms. That's all I mean by with the highlighting there. So as you can see, I've highlighted the x terms in yellow. I've highlighted the constant terms in green, and then I'm just going to add or subtract them. So I got 4x minus 2x. If I've got 4 of something and take away 2 of it, I've got 2 left. I've got 2 x's left. 7 plus 5 equals 12. And finally, I do my last operation, which is I'm going to divide both sides by 2. So if I divide the left side by 2, I get just 1x, or x. If I divide the right side by 2, then 12 divided by 2 equals 6. Remember, we can check any answer by plugging it back into the equation. We could do a formal check, or we can just do an informal check by sticking 6 back in. If I go back to the original equation, back up here, and if I do 4 times 6, that's 24. Take away 5 is 19. And then if I do the opposite side, 2 times 6 is 12, plus 7, that equals 19 as well. So the left side equals the right side. So that's one way to check. For questions like number 2, I've got 2 ways I could do it. I could either do distributive law to expand that 3 into each or into the brackets by multiplying it times each of these terms, or I could just start by doing reverse order of operations, which I think is the way I'll go for this one. Neither one's wrong, but I'm just going to pick one. So reverse order of operations means that in this case I should save what's in the brackets for last because it normally comes first. So I've got 3 times the brackets. So if I divide both sides by 3, if I divide the left side by 3, I get rid of that 3 that's out in front of the brackets. And if I divide the right side by 3, then it'll end up equaling 12. So I'll have x plus 4 equals 12. And then if I subtract 4 from each side, I get x equals 8. And remember, I can stick that back in. Again, I can go up here and I can put 8 into the equation and follow order of operations. 8 plus 4 is 12, and then 12 times 3 is 36, and so that checks out. Sometimes we have equations that have fractions in them. In that case, it's often a good idea to get rid of the fractions first. So I'll say that again. You probably want to get rid of any fractions first. So the way we can do that is we can multiply both sides of the equation by whatever the lowest common denominator would be. So 2 goes into 6, so the lowest common denominator for those two fractions I see there is 6. So if I were to multiply each term in this equation, every single term, by 6, so that's to be a times sign, so times 6 in each case, what's going to happen is I'm going to get 6x over 2 plus 24 equals 6x over 6 plus 54. And then I can simplify that. I'll get 3x plus 24 equals 1x, or just x, plus 54. So the first thing we always want to do is get rid of the fractions. Then I can carry on as normal. So again, I've got x terms, I've got constant terms, I want the x terms on the left side, so I'll subtract that x, I'll bring that x to the other side and make it a subtract x there, leaving the 3x where it was. I'll keep the 54 where it is, and I will subtract 24. And so those like terms are collected. Again, that's all the color coding is meant to show. I've got 2x equals 30. I'll divide each side by 2, and I get x equals 15. Pardon me. All right, and then same thing for the last one. I've added an extra one in here. You can see I've handwritten it in, but the approach is the exact same. I need to get rid of fractions first. What's the lowest common denominator for 3 and 4? Well, the lowest number they both go into is 12. So I want to make my lowest common denominator be 12. If I multiply everything by 12, then I will be able to get rid of the fractions. So I'm just going to write 12 times each thing, just to show you. You don't actually have to write down this times 12 each time, but I want to do it so that you can see it, so you know what I'm doing. So I'm multiplying each term by 12. So I'll get 12x over 3 minus 12x over 4 plus 24 equals 84. And then if I simplify my fractions again, I'll be able to get rid of the fractions. I'll get 4x minus 3x, and I can, well, I'll do it in the next step. So I'll just write this out. And then again, I've got like terms, x terms. These are constant terms. And so then I've got x equals 84 minus 24. And so x equals 60. And again, you can check that by plugging it back in. I won't do that right now, but that would, if I got the same thing on both sides of the equation, 7 in this case, I guess, both sides of the equation, that would prove that 60 is my correct answer.